All right, so I'm working off of your packet. If you are in my regular Algebra 1 class, then you would be looking at packet number 1. And if you are in my Algebra 1A class, also known as TARS, then you would be in packet number 2. I'm going to skip the warm-up. That's a review from Unit 2, but I'm going to move on to the bottom half of this page. When we are graphing with inequalities, we're going to graph the line just like we would if it was y equals mx plus b, but the only difference is now there's an inequality instead of the equal sign. So we're still going to look for the y-intercept and we're still going to use the slope to plot our points, but the inequality is going to mean two different things for us. The first, it's going to tell us whether or not we are going to use a dashed line or a solid line. So like we did in Unit 2 when we had inequalities, we either used an open, empty circle or a closed circle or a closed point. If it was open, that meant that the solutions went all the way to that point but did not include that point. If it was a solid point, then that meant that that point was included as part of the solution. And so now, when we graph our lines, we're going to either use a dashed line or a solid line. And my rule of thumb, what I've said to you guys in the past is, if it does not have the extra line underneath, then do not use the extra ink to color in the line. If it does have the extra line underneath, so it's greater than or equal to, or less than or equal to, if it does have the extra line, then use the extra ink to color it in and make it a solid line. If it's a greater than symbol, either one of them, then we're going to shade up. And if it's a less than for either one of those, then we're going to shade down. So the two things we're going to consider when we graph these, we're going to do everything exactly the same as we've done in the past, but we're either going to use a dashed line or a solid line, and then we're going to shade either above the line or below the line. So if I take a look at this one, I know that my y-intercept is -5. 1, 2, 3, 4, 5. So there's my y-axis, there's my x-axis. And then my slope is -1, which we want to think of as a fraction, so -1 over 1, which means I'm going to go down 1 and I always move to the right. Down 1 over 1, down 1 over 1, down 1 over 1. So now I need to determine, am I going to use a solid line or a dashed line? Because this inequality is a greater than symbol, it's just greater than. It's not greater than or equal to, it's only greater than. So I'm going to use a dashed line when I draw this line in. This is going to represent the boundary line for where the solutions are going to be found. And then, and actually make notes to yourself. So this symbol tells me that I'm going to do a dashed line, and because it's a greater than symbol, greater than, I'm going to shade up. So for that, I'm going to put my pencil on the line, and if it's shade up, I'm going to go directly above, and I'm going to color in that entire region. So the shaded region represents where the solutions to this inequality can be found. I'm going to explain that more on the next page. So in the meantime, hit pause and ask yourself, can you graph these? Because you can definitely plot the points. We did that all in Unit 4. You know how to plot these points, but the question is it a dashed or a solid line? Do you shade up or do you shade down? So hit pause and beat me to these answers. My y-intercept is -5. My slope is 3/5, so I'm going to go up 3 and I always move to the right. So now that I've plotted the points, this is the only thing that's new. Is it a solid line or a dashed line? It has the extra line underneath, so I'm going to use the extra ink to color in the line. It is a solid line. And then I'm asking myself, do I shade up or shade down? It is a less than sign, less than or equal to, so I put my pencil on the line and I'm going to shade directly below, and anything that my pencil just touched, I'm going to color in that region. Again, if you haven't tried 7 yet, hit pause and try to beat me to this one. The y-intercept is at +1, and then my slope is 6, which means it's up 6 over 1. And then I can continue that in the opposite direction if I want to, as long as it stays in that path of where the line is supposed to be. I don't think I went down far enough. 1, 2, 3, 4, 5, 6. Oh yeah, I did. Okay, and then I'm going to ask myself, is it a solid line or a dashed line? It's a dashed line because it does not have the extra ink underneath. It doesn't have the extra line, so I'm not going to use the extra ink to color it in. And it's a less than sign, so I'm going to shade down. This one is a little tricky with the shading, like where's down, but if you put your pencil right on the line, you go directly below, this is the side I'm supposed to be shading in. All right. Is it a solution? So I told you I was going to explain solutions a little bit more on the next page. A solution is any point that can be found in the shaded region. So inequalities, like this inequality, this line has been graphed up here. So these are the same thing, they go together. It's saying y is greater than this. Greater than, there's an infinite amount of points that would be greater than that line. And so we shade it in to show that that whole shaded region are the possible solutions. So here is kind of a little test to see if you understand. Circle the points that are a solution and cross out the ones that are not. For example, if I go to the point 5, 0, it's here. Does that point belong to the shaded region? Yes. So this point is a solution. It's one of many solutions, one of an infinite amount of solutions. So hit pause and see if you can do the rest of these correctly on your own. -4, +1, yes. -3, -3, no. -3, -2, okay, this one's tricky. It falls on the dashed line, but the dashed line means it's not included. So this is the boundary line where the shading stops, and that dashed line means it is not included as a solution. 0, -4, yes. -6, 0, no. If that didn't make a lot of sense, then hit rewind and play that one more time. So we can prove whether or not something's a solution 2 different ways. The first way is we can find it on the graph, and if it's in the shaded region, we know it's a solution, and if it's not, then it's not a solution. However, we can also prove it algebraically. So I'm going to prove that using these 2 up here. In the event that I want to prove this point, I already know the point 5, 0 is a solution because it was here in the shaded region. But now I can prove it by plugging it into this point, because this is an x and a y. So I'm going to plug in, instead of y, I'm going to put 0, and instead of x, I'm going to put 5. -5 minus 5 is -10. Is this a true sentence? Is 0 greater than -10? Yes, this is true, which means it would be a solution to this inequality, which we already know is true because we proved it when we graphed it. However, what if it's not? We know that -6, 0 is not a solution. So I'm going to prove it algebraically so you can see what it would look like if we decided to prove it algebraically. Same thing, I'm plugging these points in that I know are not going to work. Two negatives, make a positive. Is 0 greater than 1? No, that's false. Because I was left with a false statement, that means that this point does not belong to the solution region, and we know that because it was way over here in the unshaded spot. So there are two ways you can prove whether or not it's a solution. Algebraically, if you're left with a true sentence, then it is a solution, and if it's false, then it's not. Or you can graph them. So I'm going to encourage you to hit pause because I'm going to put these answers very quickly. Try to beat me to these answers. Hit pause. 0, 0, no. 0, negative 4, no. 5, 3, no. 4, negative 5, yes. 0, negative 5, that one's tricky. It landed on the solid line. A solid line means it is included in the solution set, so yes. 5, negative 2, again, tricky, but yes. Finally, for these ones, we're still using the form y equals mx plus b. The only difference is that instead of an equal sign, I need to use the appropriate inequality, which I could figure out right away. I can already tell it's a dashed line, and it looks like we shaded below the line. So I can tell you already that it's going to be a less than or, not equal to. Let's white that out. Okay, it does not have the extra ink to color in the solid line, so I'm not going to use the extra ink to write the line underneath. And then I've got y, and then this is where my equal sign would be, and now I need the slope and the y-intercept. So over here it's asking you to identify the slope and the y-intercept.
Rich Palmer, please call extension 2304. Rich Palmer.
This is not a great line, so we're going to use the points 1 and negative 5 as points that look like they belong to it. So that means the y-intercept we're going to say is positive 1, and then based on this slope triangle, it kind of looks like it's going up 6 over 1, which is 6. So this becomes 6x plus 1. But the only thing that's new is writing the correct inequality in that spot. So hit pause and see if you can beat me and do this one correctly. So my slope looks like it's going up 2 over 3. Remember, it's rise over run. The y-intercept is at negative 5. So the only thing I don't know is the inequality. And if I put my pencil on the line, it looks like I shaded down, so it's a less than. But is it less than, or is it less than or equal to? It has a solid line, which means we use the extra ink to color in the line, so I'm going to use the extra ink to draw the line underneath.